more. And you only need to send a small number of people to learn.
And it's true. Every little bit counts.
AFM. You are listening to a universe of possibilities. This is Astronomy FM.
Coming up next, an Astronomy.fm original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy. AFM Radio, AFM Radio, AFM Radio, AFM Radio.
Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening. I'm Dr. Elena Hyde, the director of the observatory, and I'm joined tonight by Sana. We are broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. This is Science Night in Canada, where the lineup is all Canadian, starting with ourselves, York Universe, and then on to Western Worlds, Quirks and Quarks, and Science for the People. York Universe broadcasts every Monday night, in case you hadn't realized, 9 p.m. local Toronto time, or Tuesday morning at about 2 a.m. UT. The York Universe production works in concert with our online public viewing program run by our amazing observatory team, which runs at the same exact time, so that means it is actually on right now, 9 to 10 p.m. local Toronto time. If you want to follow along over on YouTube with our observatory team for online public viewing, you can head over to yorku.ca/science/observatory and follow the links to OPV for online public viewing. They've got a live chat over on YouTube. You can also go directly to YouTube and search for the York Allan Carswell Observatory or York Observatory. Our broadcast is powered by and in partnership with Astronomy.fm, the voice of astronomy. For any questions or comments you have about our past shows or suggestions for future topics, no aliens please, send us an email at observe@yorku.ca. You can always connect with us on Twitter, where our handle is @York Observatory, or Instagram with the handle @YorkU Observatory, and Facebook at Allan Carswell Obs, just to have the full range of names there for you. All of our programs are free, but if you'd like to make a donation, you can also see that same website I mentioned before, yorku.ca/science/observatory. Our crew is monitoring the YouTube chat for questions and to post content to entertain you. The current weather is not great. It is, in fact, still snowing. It's not snowing at the observatory, but it is snowing just south of the observatory where I am. How about for you, Sana?
It was snowing kind of on and off today, but I don't think it's snowing right now.
Yeah, it is. It has been just abysmal weather.
Yeah.
Toronto in January, oh my gosh. Well, January is almost over. So hopefully the change of the month will lead us towards some clearer skies. There's all kinds of interesting stuff up there. But due to the snow and ice, our crew over on OPV is probably showing some very pretty stock images. They do actually have images of the comet. I'm not sure if they're going to put them up right away, but we were able to get some pictures last week thanks to Sana. And who was it that went with you, Sana?
It was Zaina and I.
Yeah, great comet viewing very early on. It hasn't been really clear since then.
That was the one clear night of the month.
Yeah, and we did get two very nice pictures of the comet for our efforts, but fingers and toes crossed that tomorrow or perhaps the day after does clear up so we can catch that. We'll probably talk about the comet a little bit more later on in the show. All right, so let's go ahead, and speaking of the show, we've got all kinds of interesting facts and lots of news items to entertain you with tonight. Astronomy, there's always something going on. But Sana, why don't you go ahead and take us back in time a little bit first?
Sure. So going all the way back to 1971 now, so this is kind of a triple This Week in Space History item because it's all related to Apollo 14. So January 31st was the anniversary of the launch of Apollo 14. Then February 4th, the anniversary of Apollo 14 landing on the moon. And a sort of bonus history item here is it was the first time that a golf ball had ever been hit on the moon on February 6th. One of the astronauts brought a golf ball with them to the surface of the moon and hit a golf ball with a makeshift club. So pretty, I think, pretty funny bonus this week in history item for Apollo 14. But anyways, getting back to the actual lunar exploration of Apollo 14, this was the 8th of the crewed Apollo missions, and then the 3rd crew of the Apollo program to land on the moon. As with all of the Apollo missions, there were 3 crew members, Allan Shepard acting as the commander of the mission, Edgar Mitchell, the lunar module pilot, and then Stu Roosa, the command module pilot, who would actually stay in orbit around the moon for in this case, 2 days, that Allan Shepard and Edgar Mitchell were kind of messing around on the surface of the moon. So this crew is actually kind of an interesting crew because Allan Shepard was actually part of the original astronaut group, the very first astronaut group at NASA, which were nicknamed the Original 7 or the Mercury 7, since there were 7 astronauts who would all fly part of the Mercury program. Allan Shepard was the first American to fly to space and then the second person to fly to space after Yuri Gagarin in, I think it was 1961 around, I believe. And then the other 2 crew members were had actually never flown to space before this mission on Apollo 14. So pretty interesting setup for this crew. So this is a pretty big moment for Allan Shepard in his career as an astronaut as well, because despite being the first American to go to space, that was one of his only flights to space. He got grounded only a few years after that mission because of a health condition he had. It caused fluid buildup in one of his ears, which would give him these random and temporary spouts of like dizziness and even deafness in one of his ears, which you obviously can't fly to space if you're having those random episodes like that. So he, much to his, he was very unhappy about it, but ended up being grounded for several years until he was eventually cured of this problem through a surgery that he had and placed on Apollo 14. So pretty interesting crew makeup, I think. Anyways, this crew ended up landing in a region called the Fra Mauro Highlands, which was the first mission to the highland regions of the moon. The 2 previous Apollo missions that landed on the surface, Apollo 11 and Apollo 12, landed in the lunar Maria regions. So these are just darker areas. These are the darker areas of the lunar surface, and they're also the younger areas of the lunar surface, which were created during impacts between some asteroids when they collided with the moon. They cracked the surface, and then at the time there was lava that was underneath the surface that was hot enough to be able to seep to the top onto the surface of the moon and fill in these big impact basins, creating the lunar Maria. So the previous 2 missions had been to those regions, but the highland areas of the moon, they're brighter and younger regions. So it's kind of a different part of lunar history that you're investigating when you basically pick up samples and explore these areas, which is why the geologists had decided to send astronauts to the highland regions for Apollo 14. The region, the Fra Mauro Highlands, was of particular interest to geologists, primarily because it consisted of material that was ejected during the Imbrium impact. So this was the event billions of years ago that created the Imbrium crater. It's on the near side of the moon. It's one of the biggest impact craters on the surface of the moon. So it's a very, very important part of lunar history. And the Fra Mauro Highlands consists of it just has a ton of material that was ejected during this Imbrium impact. So the idea was that you send astronauts to this area, they can collect samples from there. They can do a lot of stuff like age date the material that's there and figure out how long ago the Imbrium impact was. So it was a pretty important region for them to be able to explore. And it was actually so important that when the Apollo 13 mission failed and the astronauts were not able to reach the lunar surface, instead of just picking a new landing location for Apollo 14, they decided to take the Apollo 13 landing site of Fra Mauro and transfer that over to Apollo 14. So it was a very important region for astronauts to be able to explore, to study the history of the moon, which is why they selected it twice, essentially, for astronauts to explore, even though they only ended up exploring it once. So this was the last in the series of what is called the H series missions to the moon. So the different Apollo missions were split up into different categories based off of primarily how long they were going to be staying on the moon and what they were going to be doing. As with all of the H missions, Apollo 14 was a 2-day stay on the moon, which involved 2 moonwalks. During their first of their moonwalks, astronauts primarily deployed experiments and then picked up samples around where the lunar module had landed. Among the experiments, there were a bunch of different things that were deployed on all of the Apollo experiments. And as with all of the other Apollo missions, one of the experiment packages they deployed was ALSEP, the Apollo Lunar Surface Scientific Experiments package, which included just a bunch of different suite of experiments that would study the lunar environment. So things like the gravitational field, the radiation environment, seismic activity, things like that. And the point of having the same kind of experiment on all of the Apollo missions was that you could get data points from different areas on the moon to see if there were any differences, just to kind of figure out the general environment on the moon, if it stays the same, if it changes with location. So they deployed all of those experiments during their first moonwalk. And then on the second moonwalk, the day after, their goal was to scale to the rim of something called Cone Crater. This was a small crater that was located within the Fra Mauro highlands. And while they had planned to reach the rim of the crater, they didn't quite get there. They had some serious navigation issues when they were on the surface. In order for them to navigate, they basically just relied on landmarks from around them. But those landmarks look very, very different when you're actually standing on the surface of the moon looking around versus the maps that they studied, which had been taken from lunar orbiters. And they just kind of essentially kept getting lost, had a really hard time figuring out where they were. And after a while, mission control told them, like, this isn't worth it. You just kind of have to pack up and go back to the lunar module and make sure you get back there safely. So they ended up leaving before they actually reached the rim. And very annoyingly, they later found out that they came within 20 to 30 meters of the rim of the crater, but just weren't quite able to reach it. So if they'd stayed out there a bit longer, they probably would have reached the rim. But it was very annoying that they missed it by only that tiny amount of distance. But despite those issues with reaching Cone Crater, and even despite some of the issues that they had early on in the mission, there were some problems right after they launched of docking with the command module to the lunar module, which they would need to go to the lunar surface. It took them like 6 attempts to get it to dock, so it was a very frustrating time, and they were actually worried at some point that they might have to call off the entire mission if they couldn't dock to the lunar module. But despite those issues, they were able to dock with the lunar module. They were able to collect a lot of really valuable samples, nearly 100 pounds of samples that they collected while they were there. As expected, most of the rocks that they collected were these things called breccias, which formed during the Imbrium impact. So these are rocks that are formed during insane impacts like Imbrium. There's very high temperatures, very high pressures that make kind of unique rocks. So as expected, most of them were rocks created during that process. But they also ended up finding some basaltic rocks. I think I'm saying that correctly. And these are rocks more like you would find in places like the lunar Maria, because they're created from lava flows, basically. So it was a little bit unexpected that I think that they would find some of those rocks in the highlands where you wouldn't really expect them. But the interesting things about these is that they were much older than the basaltic rocks that were found at the in the Lunar Mariah in the past 2 missions that landed on the surface. So some of them were up to 4.3 billion years old. So these are very interesting samples, even if they weren't created during the Imbrium impact. And like one of the main science goals, like I said before, of sending astronauts to the Faramaro Highlands was to determine how long ago the Imbrium impact took place. And they were able to determine how long ago that happened, about 3.93 billion years ago. So definitely very successful mission.
Absolutely. And of course, so much going on there with the moon. I just love the, I think that the golf playing story is always going to be a favorite. I'm just waiting until we go back and have a basketball team up there.
It's interesting to see all the silliness that astronauts get up to.
Well, give people enough time and they will definitely get silly. And it's so worth thinking about the moon. It is, if you do have any clear skies tonight, the moon is about 73%. And it's annoyingly bright given that people are out there trying to see a super, super dim comet. But it is, worth a thought, thinking about our celestial neighbor. And of course, with the Artemis program now being on for next year, I think it still says 2024. So Artemis 2 still says 2024 online, and that will put humans back on the moon eventually. Although not in any of the locations you mentioned. They're planning on going to the pole actually and landing but possibly near some water ice on the moon, which would be, again, that's a south polar region. There's so much of the moon that we haven't explored. It's and it's not at all surprising that they had trouble navigating their way around this completely alien landscape.
Yeah. I forgot to mention this, but one of the other significant parts of this mission is that it was the most accurate landing to date of any of the Apollo missions. Apollo 11 had some problems in terms of their landing, like the location that they were landing, and they ended up being way off. And the computer was trying to land them in a place with a lot of boulders where you can't actually put a spacecraft down. So it was kind of a big deal on Apollo 12 and eventually 14 of doing a pinpoint landing and landing where you're supposed to, or landing where you're expecting to. So that was another interesting thing about Apollo 14. And, yeah. And hopefully on the Artemis missions, on Artemis 3, when they actually land, there'll maybe be some better equipment or better computers that can deal with the navigation.
Well, the pinpoint landing has worked on Mars, with, of course, the Curiosity rover being sort of notoriously lowered down on that beautiful jets. So I'm quite hopeful that the future moon landings will become at least more precise. And it is worth looking those up, actually. Some of their early landing sort of circles or ovals, they're gigantic. They're just like, we'll be anywhere in here would be fine. Just anywhere in this crater would be a win. But yeah, it is actually astonishingly difficult, the technological challenges in going to the moon, which I'm sure is part of the reason why it's been so tough to get back.
Yeah, it would be interesting to go to the far side of the moon.
Oh yes, absolutely. Of course, with all the craters there, you'd have a ton to explore. Although, I have to say, I think that the South Pole is pretty interesting as well. So I think a lot of us are quite keen to see just what kind of water is in that crater.
Oh, yeah. Yeah, South Pole, South Pole is probably definitely a better place to start than the far side, because that brings a whole other list of issues exploring the far side. But I'm very excited for a South Pole mission. It'll be very interesting.
Oh, yeah. Well, and if you have a lunar gateway in orbit, in theory, you would have some sort of support from that for navigational purposes, perhaps. Yeah. Maybe we'll even have a lunar GPS at some point in. But anyways, the moon is pretty awesome, and it is always worth thinking about the amazing explorations that have happened and how much there still is to go. So I always love talking about the moon, and it's up right now. So. All right. Well, how about we go ahead and talk a little bit more about the moon, actually. So I figured I would stay on the moon track here and just use my This Week in Space and Astronomy History fun fact to be something that happens every year. So again, I'm cheating a little bit. I've done this before on our program, but it was the Lunar New Year, and we really didn't get to talk very much about it. And the Lunar New Year is really interesting because, of course, it's based off of a lunisolar calendar. And this year in history, at some point between 771 and 476 BCE, the Chinese traditional lunisolar calendar came into place. And before this time, solar calendars were primarily used, and they sort of switched into the lunar solar calendar. This year, 2023, the Lunar New Year took place on January 22nd, 2023. So I am a little bit behind the curve on it. However, since we're going back to potentially 771 BCE, I think I can increase my error bars just a little. And lunar calendars are really interesting for humans because watching the phases of the moon is something that we have been doing as humans for 30,000 back to 50,000 years old, for actual oral records and rock art that has occurred on Earth. And probably even longer than that. It's just that our records get very, very bad after 10,000 years ago. So it is really interesting to note that phases of the moon and the full moon to full moon pattern that sort of occurs every month or moon, as it used to be, that astronomical new moon after, of course, the solstice was a particularly valuable time of year to mark. And different types of calendars, of course, being a little bit different with how they mark time and what phases of the moon they use, means that we have all kinds of really, really interesting combinations. You can have a lunar calendar, which is purely based on the monthly cycles of the moon's phases. So you have just the phases of the moon. I'm watching full moon to full moon, or new moon to new moon, or crescent moon to crescent moon. And a purely lunar calendar is distinguished from a lunisolar calendar. So a lunisolar calendar is where you use the moon to create sort of months or moons, but you bring it into alignment with the solar year by some process of calculation. So sometimes people would insert a leap month to make sure that the years would also restart after, for example, the equinox or a solstice even. So it's really interesting how different types of calendars have come into play, and we're not going to talk about all of them. There's a few that are based on the first sighting of the lunar crescent, which is I had to give a special shout out to the Hijri calendar, which is observed by most of Islam. So I hope I'm saying that right. But it's based off of your first sighting of a lunar crescent, which is just after the new moon. And of course, the Chinese calendar, which is celebrating its new year, that is a lunisolar calendar where the first day of a month is when the astronomical new moon occurs in your particular time zone. So in other types of lunar calendars, for example, in Hindu calendars, the month might begin on the day after the full moon, which is a very actually easy thing to set up and to watch. So when you're thinking about the Lunar New Year for 2023, of course, it has a lot of festivals that have come about because of this Lunar New Year. It's actually one of the longest of all Chinese festivals, and it's celebrated all over the world. So even here in Toronto, there were Lunar New Year's activities, banquets, and of course the lion and dragon dances. And the Lunar New Year does go back quite a ways. And this particular Lunar New Year festival is thought to go back maybe even to prehistory, which means we really don't have written records going back far enough. It's the new lunar cycle. It's the spring festival in the northern hemisphere, and it falls sort of between that December solstice that we've all seen now and the March equinox. So we're going towards March, and once we hit March, we all know it'll start getting a little bit better weather-wise here in Toronto, and that's because, of course, the daylight starts to get more prominent. So just as a little note of interest, China today actually does follow the Gregorian calendar, which is commonly used here in Toronto. That's the one you probably have on your desktop. But the Lunar New Year is still really, really important for festivals and the traditional Chinese calendar. It's a wonderful calendar, and I highly advise everyone to have a look and to read a bit about it. It was, of course, developed a very, very long time ago. As I say, we aren't sure when exactly, between 771 and 476 BCE, that it came into prominence. This was part of the Eastern Zhou dynasty, and before that they were using a solar calendar or a 5 elements calendar, which is really quite interesting stuff. So lots and lots of fun to be had with the moon today here on York Universe. So I'm not going to take too much time, but happy Lunar New Year to everybody who already celebrated it, I'm sure, back on January 22nd. And let's go ahead and switch into something a little more recent, I suppose. So I've taken us back to potentially prehistory, but it is very, very interesting how some of these calendars come about.
Yeah, I don't know too much about how different calendars are created, so that was an interesting bit of history there. But yeah, it's really interesting how just people create calendars.
Yeah, and there are some places on Earth. I always say calendars came into being over such an incredibly long time period. Today we have no concept of how things change over thousands or tens of thousands of years, because right now we're seeing change that's very, very rapid, on the order of not even just 100 years, but even 10 years or 20 years, huge dramatic changes. So these calendars that stretch back through the ages were developed really, really locally. And it was your position on Earth that determined what types of celestial things were going to be most relevant to you during the year. If you're in the northern or the southern hemisphere, you might have a lunisolar or a lunar calendar that is really, really accurate. But if you're on the equator, when the sun's position doesn't change a lot, a solar calendar isn't going to be very useful. And so there's actually really interesting calendars that have been developed off of the Pleiades and various different star configurations. It's fascinating stuff. So I love calendar calculations and calendar inventions, and there's some really interesting ones out there, and it can help you really understand more about your particular location on Earth if you look up some of the historical calendars that used to be in use thousands of years ago. Anyways, that's a different York Universe episode.
An entire episode on the history of calendars.
That's an excellent idea. Maybe not next week, but once we have time to write it up.
Yeah.
All right. So, Sana, do you want to take us to something a little bit different, not necessarily calendar related?
Sure. So this was an interesting discovery regarding this star Sirius. So Sirius is the brightest star in our sky, and it turns out, so this is something that's common knowledge now, but back in 1844 it was assumed basically that Sirius was just a single star, but it turns out that it's actually not. It's in a binary system. So the original, I guess you could say the original, not really discovery, but calculations that led to the discovery were made back in 1844 by German astronomer, I'm going to butcher this name, Friedrich Bessel. That was probably completely wrong, so I'm sorry about that. But he was monitoring the motion of the star Sirius, and he noticed that the motion was a little bit odd. So basically he predicted at that point, based off of how the motion of Sirius was a little bit weirder than he would have expected, that there was a companion star to Sirius. So in 1844, binary stars had already been discovered. There had been several of them that had already been detected. But the difference with Sirius was that they couldn't actually see a companion star. So when they looked at Sirius, all they saw was just one star. They could not resolve a second one. But the astronomer Bessel said that there has to be a companion star to it. We just can't see it right now with the current instruments that we have. So fast forward to 1862, on January 31st, that companion star was discovered by two people who had no idea that the existence of a companion star had already been predicted. The actual discovery then was made by father and son Alvin German Clark and Alvin Clark, who were telescope makers. They were testing out an 18.5-inch refracting telescope, which was going to be the largest refracting telescope in the world at the time. And as part of their test, they pointed it at Sirius and were quite surprised to see a small companion star around Sirius. Like I said, they didn't know that an existence of a companion star had already been hypothesized and that they had just detected it, but it was significant enough for them to report the discovery to the Harvard College Observatory. The director of the Harvard College Observatory then about a week later used the 15-inch refractor at Harvard to observe the system and basically confirm the discovery that was made a week prior of this companion star. So still at the time, while this companion star was discovered, it wasn't exactly known what it was. And it turns out that the companion star called Sirius B isn't a normal main sequence star. It's a white dwarf star. These white dwarf stars are created when stars that are about the same size as the sun and also a bit more massive than the sun, about 8 times solar mass, I believe. When those stars finish the hydrogen fuel in their core, they puff up into red giants and then eventually shed those outer layers, leaving behind a white dwarf. These white dwarfs are very small. They're very compact, primarily made of carbon and helium, and they're not really doing anything much else apart from just kind of sitting there. There's no fusion reactions going on in the core, and that makes them pretty dim. They're basically just radiating away residual heat that was left over from the death of the main sequence star. And since they're not really producing any extra light, they are very dim. I've actually heard them be called the hot potatoes of the universe because that's really all they do. They just sit there and radiate away energy instead of doing anything. But it's now known that Sirius B is a white dwarf star, and it's now known as the first ever white dwarf star to be discovered. And since it's a white dwarf, this is actually why it wasn't detected in, 1844, when its existence was first hypothesized, because it is so dim. It's about 10,000 times fainter than Sirius A, so the bright star that everybody sees. So it was very hard to basically resolve the pair at all, which is why it wasn't able to be detected back in 1844 and took bigger telescopes with better optics to be able to finally detect the system. So yeah, it's now known that the bright star that we see in the night sky, Sirius, is actually Sirius A, and it has a very small white dwarf companion called Sirius B. There's been quite a bit of research into Sirius A and B ever since it was discovered that the pair were actually a binary system. Sirius B can be a pretty interesting thing to study because it is a white dwarf star, and studying white dwarfs and stellar remnants like Sirius B can actually tell you a lot about stellar evolution. So just a couple quick interesting facts on the system. Sirius A is currently a main sequence star, so it's about 225 to 250 million years old, has a mass about 2 times the mass of the sun. And then Sirius B was a medium mass star before it exploded and created a white dwarf. It was about 5 times the mass of the sun while it was still alive on the main sequence, which made it a B-type star. It ended up dying about 124 million years ago, creating a red giant temporarily, and then eventually a white dwarf. The white dwarf itself weighs only about 1 solar mass. So it is still decently massive object, but it's very small and very compact, which is kind of what makes it another part of why it's pretty hard to see, because it is very, very small. Sirius A and B also orbit each other over a period of about 50 years. They're in a very elliptical orbit, so the distance between Sirius A and B changes a lot during the orbit. But on average, the distance between the two is about 20 astronomical units. So the pair is very interesting to observe. I know I've seen it through the 1 meter before. It's really cool because Sirius B is so much fainter than Sirius A, so it's a really interesting pair to look at, but it's also a lot of fun. If you have a telescope at home that's at least 4 inches in diameter, you will be able to resolve the two. And right now is actually a pretty good time to observe them because they are closest to their maximum separation between each other. So you have kind of the best chance of seeing them when they're further apart than when they're very close together, because there's less of a chance that Sirius B will be kind of obscured by Sirius A because of how bright it is. So if you want to take a look at the pair, now is a very good time to do it. And it's definitely a very cool thing to observe. It was a little bit hard for me to believe the first time I saw it that little thing right beside Sirius A was actually a white dwarf star, because it's so tiny.
Absolutely. And it is a really fun little sort of starter project for binary stars. If you can find a binary star that's actually an observable binary, that in itself is actually kind of rare. Yeah. But this is a great system. And of course, supported by electron degeneracy pressure, this incredibly dense object is something that is not a normal star, right? So that's something that is always worth emphasizing on these programs, is when you have a white dwarf star, it's not shining because of the same reasons our sun is shining. It's shining because it's incredibly, incredibly hot. It's radiating out very, very, very high temperatures. And as it radiates away its energy, it does gradually cool over time. So over the lifetime of the universe, a white dwarf, in theory, could start to even crystallize, which is such a cool idea. But it will take a very, very long time. So this is going to be something like larger than the current known age of the universe. So the universe, I think, is something around 14 billion years old or so. So longer than that. So it should be technically impossible with the universe's age for any white dwarf to have completely crystallized. But it is very interesting to think about, because this isn't just an electron degeneracy supported object. There's carbon oxygen white dwarfs, and people have made the point before that if you crystallized this carbon object, would you just have a gigantic diamond? And they're so interesting. Of course, they have that limit, the Chandrasekhar limit. You can't have more than 1.44 times the mass of a sun in a white dwarf, or it'll collapse into a neutron star. Of course, our sun will not make a white dwarf large enough for that, so no worries there, I suppose. But they are just really, really fun, strange, tiny, massive objects.
Yeah, do you know if there are any other white dwarfs that you can see through a telescope? I'm not sure.
Yes. But I can't pull a list out of my head at the top right now. But there are a few. That you can just see. I mean, especially if you have a larger telescope. We do have the 1 meter on campus, so there are a few, but it is not, it's not very common. They're, as you say, they're very, very small. So usually white dwarfs are detected as remnants that have been inside of stars. So you might detect the nebula first and then the white dwarf sitting at the center later. Or you detect them in orbit around other stars, and you can see their effect on that star's movement and then get the mass. And once you have the mass, you know whether or not it can be a white dwarf or a neutron star. because of that wonderful, wonderful white dwarf limit. But yes, there was another one. The name escapes me. All right, so white dwarfs, diamonds in the sky. Now we'll go ahead and I think go ahead and get into our reminders in a second. But speaking of reminders, I need to remind you all that you are listening to York Universe, broadcasting live from the Allan Carswell Observatory located at York University in Toronto, Ontario, Canada. You can see our website at yorku.ca/science/observatory, and you can see our live OPV chat over on YouTube by going and following the OPV links from the website, or going directly to YouTube and searching for the York University Allan Carswell Observatory. Tonight you're listening to Elena and Sana, and we're currently discussing lots of moon things and giant diamonds in the sky. So if you would like to find out more, you can head on over and chat with our OPV crew by going into YouTube now. There should be live at the moment, and we'll go ahead and get going with some. I think we've got some reminders. We sort of alluded to this before, but there is, in addition to a, gosh, if only it was clear in Toronto right now, there's a wonderful moon out there that is nice and bright and easy to see right next to a beautiful bright planet Mars. The Pleiades is out, but also that comet everyone's been talking about. Sana, you want to do the comet news?
Sure. So the comet, I've been seeing so many amazing pictures online of the comet, including some of our own that we got a couple weeks ago or something. I think we were talking about earlier. But this comet is about to have its closest approach to the Earth, which is going to be on February 1st. It'll be coming within a distance of about 0.28 astronomical units to the Earth. This is a pretty significant moment for this comet because it's going to be the biggest and the brightest that it's been in our skies so far. So if you're wanting to observe the comet and haven't done it already, now is the best time to do it. Just not only on February 1st, but also I think, a few days to a week surrounding it, it'll be very, very bright, very big in the sky. So definitely a good time to observe it. It's in the constellation Camelopardalis, and if you know where you're looking, you can grab it with even like a small telescope or even just binoculars. So it doesn't take too much effort to be able to see it. I guess effort isn't the right word, but you don't need a really massive telescope to be able to see it. It's definitely really cool, green comet, multiple tails. So if you can get some clear skies, which we are apparently not able to get, definitely take a look at this comet. It's really cool.
Yeah, absolutely. And just a reminder, you will not be able to see it naked eye unless you have very good eyesight and a very, very clear sky, because it is very, very dim. It's just at the edge of even being visible to humans in the sky. I say it's in Camelopardalis. It's actually moving across the constellations night to night. One easy way to find it actually is to go outside and look for the Little Dipper, and then just look a little bit to the east of Polaris. Once you've found Polaris, if you can find the pole star, you're halfway there. So, but yeah, it is very, very dim, but good enough to see with binoculars. It's a fuzzy little patch, and if you've just got small binoculars, you might not be able to tease out the color. So don't be disappointed or discouraged. Definitely give it a try. But if you're in the city, you will need binoculars or a telescope.
If only we had perfectly clear skies and dark skies without light pollution around. That would be great.
That we'll have to go to Killarney Park for, I think. We will be doing the Astronomer in Residence again this summer, if anyone's interested, out at Killarney Park, dark sky site. So we might have to go back out there this summer. The comet will be gone by then, though. So, so I think we've got one other thing, the ISS passes. Do you want to talk about that one, Sana?
Sure. So this week, it turns out, is going to be really good for ISS passes. If you're in Toronto, there will be several passes each night, at least one really good one where it passes over very high altitudes on Tuesday, Wednesday, and Thursday night. There are a few others scattered around in there, but they're kind of lower altitudes, but you should still be able to see it. It's hard to say an exact time of when the ISS is going to come overhead because it is really dependent on your location. But if you do want to catch the ISS going overhead, you can go to Heavens Above or spotthestation.nasa.gov. And if you enter your location, they'll both give you an estimated time of when the station is going to come overhead. It's actually a very, very cool thing to observe. All you have to do is really go outside and look in roughly the right direction for when it's going to come overhead. It looks like a really bright star that's moving pretty quickly through the sky. So this is definitely one of my favorite things to observe because it's a lot of fun.
And very, very bright, which is always nice. So we love to tell people about things that you'll definitely be able to see. And the ISS is one of those ones. It's pretty fun because it's super bright. It goes zipping across. And if you've got clear skies at all, you'll be able to see it.
It's really interesting, too, because I remember there's a few times where I've been trying to observe it, and it should be coming from that direction, but I can't really see it, and it just pops out all of a sudden. So it's a really fun one, and it's always nice if you're outside observing other stuff. Just take a minute as it goes overhead, and it's really nice. You can just wave at the astronauts, and everybody likes to do that. Don't they? Yeah, I think so.
Excellent. Well, we have a really, really fun couple JWST-based news items. So I wanted to get us there faster today. There's all kinds of awesome James Webb Space Telescope things coming in left, right, and center. Of course, we had the inner workings of the dusty disk of a red dwarf star. But we have to talk about the asteroid because that was just so cool. So let's do the asteroid, the water on the asteroid, because that is we talk so much about water on the moon. We've got to talk about this one too. So I know you are James Webb Space Telescope expert, so I'm calling you in for this one.
Yeah, I am a little bit obsessed with that telescope.
It's a very, very good telescope.
Oh yeah, it's been doing so many amazing things, and this is one of them. So it's kind of a two-part. The asteroid that it has been observing recently a couple times is called Chiriclo. Am I saying that correctly?
I think so. That's how I've heard it pronounced before. So Chiriclo is what I've heard, and Chiriclo has been sort of known for a while. Largest confirmed Centaur object in such a small body of the outer solar system. It's very, very far away, but it has been imaged before. But what Webb has found, oh my gosh. Yeah. So like you said, Chiriclo has been observed several times. It was a really cool thing about this object is back in, I think it was 2013, astronomers discovered that there are actually rings on this asteroid, which is wild to me that something as small as an asteroid can have rings around it. So that was discovered back in 2013, but astronomers are always itchy to get follow-up data on objects. So in October, astronomers decided to observe Chiriclo with JWST. The rings themselves are very, very faint around this object. So even for a telescope as powerful as JWST, you can't actually directly observe the rings. So astronomers this time decided to take advantage of an occultation where Chiriclo's rings would pass in front of a distant star, would make the light from the star dim just a little bit, so it would block out the light incoming from that star, and they would actually be able to see evidence and study the rings by looking at how the rings influenced the light coming from that star.
So this is an observation that happened a little bit by chance, because it's not every day that the asteroid is going to be passing in front of a star that's bright enough to be able to use this occultation technique. But astronomers got lucky with this in October of 2022 when they pointed Webb at Chiricahua and watched its rings occult a star. So there are a couple really interesting graphics and images of this that have been floating around online. It's really interesting. It's really cool. So definitely check those out. If you look at JWST's website, there are some interesting graphics on there. So this was observation number 1 of Chiricahua that JWST did. And there's also another very, very, very interesting one that happened even more recently. This time, the same group of astronomers decided to take a spectrum of Chiricahua, in part searching for evidence of water ice. So it had been hypothesized that Chiricahua could have water ice, or could be partially composed of water ice, but it had never actually been directly observed until JWST came along. It used the instrument called NIRSPEC, or the Near Infrared Spectrograph. So it takes a spectrum of over, I think it's about 1 to 5 microns in this case, to observe in this case, observing any important water absorption features. So you'll see in the spectrum of an object, if there's water, it'll be absorbing certain kinds of light. And that's actually exactly what they found when they looked at Chiricahua with NIRSPEC. It was observing, instead of using an occultation like it did with the rings, they were just observing reflected sunlight from Chiricahua and actually saw these dips in the spectrum where water is absorbing light from the sun. So it's really fantastic that this has been actually confirmed now. It reveals a lot about the asteroid Chiricahua, which is in part that it's been subject to pretty much constant bombardment from high energy particles that are in the environment. And not only does it help to study Chiricahua itself, but it also helps with studying all of these other centaur objects. So these are objects that kind of have some properties of comets and have some properties of asteroids. So they're kind of these rocky things that look like asteroids, but they also have tails like comets do. So Chiricahua is definitely a super, super interesting object. Like you had said before, it's the biggest of all of these centaur objects. So finding water on Chiricahua is a really groundbreaking discovery for this in this field. So really cool. And I know the article did mention also that right now the observations can't really separate out any light coming from Chiricahua versus its rings, but that is on their to-do list, is trying to basically figure out what emission and absorption features are coming from which part of the object. So they can actually start to target what is the asteroid made out of versus what are the rings made out of, which is going to be really cool.
Yes, absolutely. And this is a very difficult observation to make. This is exactly the kind of thing that usually we cannot really see. It's got it's quite small. It's 51 times smaller than Earth. So it's tiny. It's 250 kilometers or so. And its rings are spread out. We think about 400 kilometers from the center, I think. But it's more than 3.2 billion kilometers away. This is beyond Saturn's orbit. So the size and the distance make it very, very hard to get any kind of real picture of this icy thing. And this is something that's really important for our understanding of the solar system, because there's so much we don't know about that icy outer solar system. We've only had, one flyby of Neptune, for goodness sakes. So, and actually Webb Neptune, anyways. There's the James Webb Space Telescope has done so much already for helping us to see some of these unseeables, right? These incredibly distant small objects. And if there is a lot of water out there in the outer solar system, that's actually kind of worth knowing. And is this ice only in the rings? Is it throughout the asteroid as well? There's all kinds of things that we can try to think about, and the spectrum is absolutely worth going up and looking for. Just keep in mind that the pictures you're seeing of like the rocky surface with the rings, those are artist representations because we still can't get an actual picture of it from Earth. It is very, very far away. It's not even in a stable orbit. So it's going from beyond Saturn to somewhere like Uranus during one orbit around the sun. So it's very unstable, and it takes about 63 Earth years for it to wobble about over there, which is not the technical term. And it is worth noting as well, if you're not familiar with these objects, the Centaur in a solar system. So this is one of the larger Centaur objects, and in astronomy, in the solar system, a Centaur is an object of some size, where it's actually going around sort of Jupiter, Neptune, Uranus, that sort of area, and they're almost always unstable orbits because they go across one or more of the giant planets, and their dynamic lifetimes of the orbits might only be in millions of years. So there's one strange one that's known to be retrograde. There's all kinds of funny things happening with the orbits of these objects. So I don't know, if you're looking for a really, really bright comet, you could always hope that one of those goes flying past. Gets knocked in and goes flying past. Not too close though, not too close. But no Centaur object has ever been photographed up close, unless you think that Saturn's moon Phoebe was actually a captured Centaur. So that's as close as we've gotten, is a picture of Saturn's moon, which we think might have been one of these types of objects. And they've all got pretty interesting names because, of course, they sort of try to theme them after areas of mythology. But it's any small body between sort of Jupiter and Neptune that sort of crosses the orbits of those giant planets. And this one being, I think it is still the largest of those objects, even though it is 51 times smaller than Earth. Having a ring and having water is really, really cool.
Oh, yeah. It would be nice to send a spacecraft out to one of these things to take a look, but I have a feeling with an unstable orbit that's not a very easy thing to do.
Yeah, I have a feeling you are quite right, and we probably have at this point better luck of funding a new telescope should decide to fly past us such that we can image it. But yeah, the water absorption features and the James Webb Space Telescope ability to pull out water absorption features not just around other stars and exoplanets, but here in our own solar system is so valuable for mapping what's out there, because we really don't know a lot about what is in the orbit with Neptune and Uranus and Pluto, for example. Yeah,
it's already done a lot of really great observations of all of these solar system objects. So really fantastic pictures, like even just apart from the science, the images that it's been taking of some of these outer planets are just amazing.
Yes, highly recommended to go and look at some of the real images from JWST, although it was not able, of course, to resolve Charico. Oh, no, I can't say it. Chariclo. Thank you.
Yeah.
It wasn't able to resolve this. It was able to tease out those ring details, and now, of course, with potential follow-up, we might even get more details out of the rings. And how much water is in what locations will be very important should humans ever decide to wander their way out into the solar system.
Yes.
So I'll just give a little bit of a shout out for James Webb Space Telescope. We're not going to really have time to talk about this too much, but if you are interested in a few of the other awesome things going on out at the James Webb Space Telescope, It also recently imaged a dusty disk surrounding a nearby red dwarf star. This was the first time this disk was ever imaged, and it was released just a few weeks ago. January 11th, I believe, was when the image came out. And it was a dusty debris disk around Au Mike, which is a red dwarf star 32 light years away. It's in the south in the southern constellation Microscopium, because the constellation there have funny names, but anyways, southern constellations. They used, again, NIRCam to study the star, and the NIRCam's coronagraph blocked the light of the central star, actually allowing for some wonderful, wonderful pictures of the debris disk around the star. And the debris disk, we think, is replenished by collisions of planetesimals. So we're really getting a wonderful window into the dynamical history of that system. Again, thanks to James Webb. And I think we'll have to probably wrap up there with a big thank you to James Webb just in general for being awesome and continuing to give us amazing things about the solar system. Well, everyone, you have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Sana and myself. Stay tuned. It is Astronomy Night in Canada. Coming up next is Quirks and Quarks, and you can always connect with us over on our website, or of course send us an email or see us on Twitter. Thanks for tuning into York Universe. Clear skies, and have a good night, everyone.
Please contact us for
Have a good
details.
night.
You may find more of our AFM original programs on our website. It's really easy to find us. We are astronomy.fm. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is astronomy.fm radio.
AFM.